Hello students, welcome to Diksha Karnataka YouTube channel. COMEDK 2024 exam has been done, right? I hope you guys have done well. So in this video, I'm going to discuss the physics paper COMEDK 2024. Okay, yeah. So let us start. Question number 1. The resistance of the galvanometer and shunt of an ammeter are 90 ohm and 10 ohm respectively. That is, resistance and galvanometer both are in parallel, right? Both are connected in parallel like this. Right? So this is the current, incoming current I, right? So at this point the current will divide. Current flowing through the galvanometer is Ig, okay? And this is the shunt resistance. Let's say this is S, okay? S. So this is I minus Ig, okay? I minus Ig. So which is equal to I dash, okay? Then the fraction of the main current passing through the galvanometer and shunt respectively. Okay, we need to find the fraction of the current passing through the galvanometer, okay, main current through galvanometer and shunt respectively. Okay, so let's find. So here the potential difference across G is same as potential difference across S, right? So Ig into G is equal to I minus Ig into S, right? Okay, so now Ig into G, right? G is 90 ohm, isn't it? 90 ohm equal to I minus Ig into S. S is 10 ohm, right? So 10 nines are 20, right? So now 10 Ig is equal to I, right? 10 Ig is equal to I. So therefore the current flowing through the galvanometer Ig is equal to I by 10, right? So 1 by 10 is there, right? In option B and C. Okay, yeah, Ig is 1 by 10. Next, we need to find current flowing through the shunt resistance, right? That is I dash minus I, isn't it? I minus Ig, okay, I minus Ig. Here I is 10 Ig, right? I is 10 Ig, isn't it? So now we need to find I, right? We need to find I dash, isn't it? I dash. So now I minus Ig, that is I by 10, is equal to I dash, right? So I minus I by 10 is 9I by 10. So I dash is equal to 9I by 10, right? So the correct option is C, 1 by 10 and 9 by 10. Okay. Question number 2. A glass of hot water cools from 90 degrees Celsius to 70 degrees Celsius, okay, in 3 minutes when the temperature of surroundings is 20 degrees Celsius. Remember, temperature of the surrounding is 20 degrees Celsius. What is the time taken by the glass of hot water to cool from 60 degrees Celsius to 40 degrees Celsius if the surrounding temperature remains the same? Okay, so here apply Newton's law of cooling, right? So what is the Newton's law of cooling? Dt by dt, that is rate of change of temperature, dt by dt is equal to alpha or S, okay, S specific heat constant, okay, S into T average minus T naught. So what is T naught? T naught is surrounding temperature, okay. So now what is dt in first case? In dt, the dt first case is 90 degrees Celsius minus 70 degrees Celsius, that is 20 degrees Celsius, right? So 20 divided by 3 equal to S into, so what is the average temperature in first case? 90 degrees Celsius plus 70 degrees Celsius divided by 2, that is 80 degrees Celsius. 80 minus 20, right? So this is the first case. Now in the second case, 70 degrees Celsius, sorry, 60 minus 40, that is 20. So 20 divided by T, we need to find the value of T. right? 20 by T is equal to S into average temperature is 60 plus 40 by 2, that is 50. 50 minus 20. This is the second case. Okay. So now divide first equation by second equation. Divide first equation by second equation. Then you will get T equal to 6 minutes. Okay. T equal to 6 minutes. The correct option is B. Okay. Correct option is B. Yeah. Question number 3. When two objects are moving along straight line in the same direction. Okay, so two objects A and B moving along straight line in the same direction. The distance between them increases by 6 meter. That is, the relative velocity of A with respect to B is 6 meter per second, right? See here, the distance between them increases by 6 meter in 1 second. That is, relative velocity between A and B is 6 meter per second, right? So VA here, VAB is equal to VA minus VB, right? So which is equal to 6 meter per second. Okay. And then if the object move with their constant speed towards each other, the distance decreases by 8 meter per second, 8 meter in 1 second. That is, object A and B both are moving in opposite direction, right? The distance between them decreases by 8 meter per second, right? So that is 8 meter in 1 second. That is, the relative velocity between A and B is 8 meter per second. So VAB in second case will be VA plus VB, right? Actually VA minus of minus VB, that is VA plus VB. So which is equal to 8 meter per second, right? So now solve these two equations, you will get VB is equal to 1 meter per second and VA equal to 7 meter per second. The correct option is B. Okay, correct option is B. Yeah. Question number 4. In the Young's double slit experiment, nth bright for red coincide with n plus 1 bright for violet. That is, the two waves are superimposing each other, right? So the interference is constructive interference. Okay. So now for constructive interference, here Yn is equal to n lambda d divided by d, right? So this is for red color. For violet color, here Yn plus 1 is equal to n plus 1 into lambda d divided by d. Then the value of n is, okay, we need to find the value of n. Wavelength of the red light and violet light is given, right? Okay, so now these two will coincide, right? So that is n lambda d divided by d is equal to n plus 1. So this is for violet, right? So this is for red. So lambda r, lambda v. So n plus 1 lambda v into d divided by small d. So what is capital D? Distance between the screen and the slit, and small d is slit width, right? So this is lambda r. So now d will get cancelled, small d will get cancelled. So now here we need to find the value of n, right? Okay, so now n plus 1 divided by n is equal to lambda r by lambda v. So what is the value of lambda r? 6300 angstrom. So angstrom will get cancelled, divided by 4200, right? So now this is equal to 3 by 2. Solve this, you will get the value of n as 2. The correct option is A. Okay, correct option is A. Understood? Yeah. Next question, question number 4. A metal ball of 20 gram is projected at an angle of 30 degree with the horizontal with an initial velocity 10 meter per second. Okay, so metal ball, it is projected with an initial velocity u equal to 10 meter per second. Mass of the ball is 20 gram, right? So what is the angle of projection? 30 degree, right? If the mass and angle of the projection are doubled, okay, if the mass and angle of projection are doubled, now the mass becomes, m dash becomes 40 gram and theta dash is equal to 2 theta, that is 60 degree, right? Keeping the initial velocity the same, the ratio of the maximum height attained in the former to the later case. Okay, we need to find ratio of the maximum height attained in the former to the later case, right? So what is the maximum height formula? The maximum height formula, h max is equal to u square sine square theta divided by 2g, right? That is, does the maximum height depends on the mass of the projectile? No, right? There is no mass term. So maximum height does not depend on the mass of the projectile. Okay. So now the ratio of the maximum height attained by the first ball to the maximum height attained by the second ball, when the mass and angle of projections are changed, right? H max 1 will be here u1 square into sine square theta 1 divided by 2g whole divided by u2 square sine square theta 2 divided by 2g. So now 2g, 1 by 2g will get cancelled, right? So now h max 1 divided by h max 2 is equal to here u square, right? So u square remains same, right? Isn't it? Angle of projection is changed. So u1 equal to u2. u1 equal to u2. So u1 square, u2 square will get cancelled, right? So then sine square theta 1 by sine square theta 2, isn't it? So sine square theta 1, that is sine square 30 degree, right? Sine square 30 degree is 1 by 4 whole divided by sine square 60 degree. Sine square 60 degree is 3 by 4. Now 1 by 4 will get cancelled. So 1 by 3, right? So the ratio will be 1 by 3 or 1:3. The correct option is C. Okay, yeah. Question number 6. The threshold frequency for a metal is N0. Okay, so N0 is the threshold frequency for the metal. If photoelectric current I is produced when it is exposed to a light of frequency 11 by 6 N0. Okay, so here the intensity of the photoelectric current is I. Okay, so it is produced when it is exposed to a light of frequency 11 by 6 N0. That is here 11 by 6 N0, this is the frequency of the incident light, so which is greater than N0, right? So definitely the photoelectric effect will takes place, right? And intensity In, okay, intensity of the incident light is In. If both the frequency and intensity halved, okay, if both frequency and intensity halved, here the intensity is small I, okay, intensity is small I. So now I dash is equal to I by 2 and the frequency is also halved, that is 11 by 6 N0 by 2. Okay, so now N0 dash, here N0 dash is equal to 11 by 12 N0. The new photoelectric current I1 will be, okay, we need to find new photoelectric current I dash, not I1, I dash. See, look at the frequency of the incident light in the second case. It is lesser than N0, right? Frequency of the incident light. So it is lesser than N0, right? So what is N0? Threshold frequency. So threshold frequency, incident light frequency is lesser than threshold frequency. Definitely the photoelectric effect will not take place, right? So the photocurrent will be 0. The correct option will be C. Okay, yeah. Question number 7. A 500 watt heating unit is designed to operate on a 400 volt line. If line voltage drops to 160 volt, the percentage drop in heat output. Okay, so the percentage drop in heat output. Remember, so what is the here heat 500 watt, right? That is the power, right? A 500 watt heating unit is designed to operate on a 400 volt, right? Okay, so we know that the power P is equal to V square divided by R, right? V square divided by R, isn't it? So R is constant. So from this I can conclude that power is directly proportional to V square, isn't it? Power is directly proportional to V square. Now here P dash divided by P is equal to V dash squared divided by V squared, right? So now P dash is equal to P into V dash is 160 volt, V is 400 volt. So 160 by 400 is 4 by 10, that is 0.4. 0.4 squared, right? 0.4 squared. 0.4 squared is 0.16, right? So P dash is equal to 0.4 squared is 0.16, so 0.16 P. So we need to find percentage drop in heating output, right? So now the percentage drop in heating output is P dash minus P divided by P into 100%. So now what is P dash minus P? P dash is 0.16 P, right? Isn't it? So 0.16 P minus P divided by P into 100%. So now solve this, you will get 84%. So you will get the answer in negative. So what is the meaning of negative sign? The negative sign indicates that there will be a drop, right? There will be a heat drop, isn't it? There will be a heat drop in the heating element, isn't it? So 84% is the correct answer. So the correct option is C. Okay, yeah. Question number 8. The current flows through the uniform square frames as shown in the figure, in which case is the magnetic field at the center of the frame not zero. Okay, so let's check each option, okay, or sorry, each situation, okay. So here the current I is incoming, here the current I is outgoing, right? So at this point the current will divide I by 2 and I by 2, right? So now apply right hand thumb rule, okay. So at the center of this square frame, the net magnetic field will be 0. So the A cannot be possible, right? So next B. Here the incoming current is I, outgoing current is I. Here current will divide I by 2 and I by 2, right? So next apply right hand thumb rule. So the magnetic field at the center of the square from B is also 0. So B cannot be possible. Let's check C. Here incoming current is I, outgoing current is I, isn't it? Incoming current is I, outgoing current is I. So now apply again right hand thumb rule. At the center magnetic field is not 0. So sorry, magnetic field is not 0 here, magnetic field is 0, right? So it is correct, C is correct. Let's check D. So incoming current is I, outgoing current is I. Here the current will divide, isn't it? So the magnetic field will be 0 at the center. So the correct option is C. Okay, correct option is C. Yeah. Question number 9. A transformer which steps down 330 volt to 33 volt. That is primary coil, voltage across the primary coil is 330 volt and voltage across the secondary coil is 33 volt. To operate device having impedance 110 ohm, the current drawn by the primary coil of the transformer. The simple one, right? So here we know that Vs divided by Vp, right? So Vs by Vp is equal to 33 divided by 330, right? So which is equal to Ip by Is, Ip by Is. So this is the relationship between voltage across the coils and the current through the coil, right? So now 1 by 10 is Ip by Is, right? So Ip divided by Is is equal to 1 by 10, right? Okay, so we don't know the value of Is, right? We need to find the Ip, right? We don't know the value of Is. So how to find the Is, right? So voltage across the secondary coil is given 33 volt, right? And the impedance of the device is also given, that is the secondary coil, right? Isn't it? 110 ohm, right? So now Is is equal to Vs by Rs, right? This is impedance of the device. Now Is is equal to Vs. So what is Vs? Here 33 divided by Rs. Rs is 110. So now this is 3 and this is 10. 11 3s are 33, 11 10s are 110. So now Is equal to 3 by 10, right? So Ip is equal to 1 by Is. Is into here, Is into 1 by 10. So what is Is? 3 by 10, right? that is 3 by 100. IP is 3 by 100. So the correct answer is 0.03 ampere. B. Okay. Yeah. Question number 10. A cell of EMF E and internal resistance R is connected to two external resistance R1 and R2 and a perfect ammeter. The current in the circuit is measured in 4 different situations. Okay, current in the circuit is measured in 4 different situations. So in which case the current is more, right? Okay. So if without any external resistance in the circuit, okay, without any external resistance in the circuit, the current will be maximum, right? If R1 and R2 is absent in the circuit, so the current will be maximum, right? In the circuit, the current will be maximum. So A has the highest, right? In first situation, A has the highest current. Okay, let's check B with resistance R1 only. Okay, in C with R1 and R2 series combination. In D, R1 and R2 parallel combination. Okay, so in series combination, the current is the lowest, right? R1 and R2 both are in series, right? So the current here, the current in the circuit will be lower, right? Will be lower compared to the D, the parallel combination, right? Compared to the D and B, right? Compared to B and D, okay? Compared to B and D. So A is greater than D, right? A is greater than D in parallel combination and D is greater than B, okay? And then B is greater than C. This is the increasing order or okay, they have given decreasing order, right? Okay, so decreasing order. So the correct option is A. Okay, yeah. Question number 11. Select the unit of coefficient of mutual induction from the following. Simple one, right? We know that M into I is equal to N into phi. This is the relationship between Mi and phi. Phi is magnetic flux, right? M is mutual induction and I is current. So now differentiate both sides with respect to t. So M into di by dt is equal to N into d phi by dt. So what is N into d phi by dt? Induced EMF. So E is equal to M into di by dt, right? So now M equal to E into dt divided by di. So what is the unit of E? Volt. So what is the unit of time? Second. So what is the unit of current? Ampere. So the correct option is A. Okay, yeah. Question number 12. Steel is preferred to soft iron for making permanent magnets because okay, the steel has more coercivity and more coercivity than soft iron. Okay, so this is the correct option. C. The direct question and theory based question. Yeah. Question number 13. A particle executes a simple harmonic motion of amplitude A. Okay, particle executes simple harmonic motion of amplitude A. The distance from the mean position at which its kinetic energy equal to its potential energy. So what is the potential energy of the particle which executes simple harmonic motion? That is half kx square, right? So which is equal to the kinetic energy of the particle, right? So what is the kinetic energy of the particle? Half m omega square a square minus x square, right? Half m omega square a square minus x square, isn't it? So k is spring constant, right? So spring constant is m into omega square into x square, which is equal to half m omega square a square minus half m omega square x square. So now m omega square, okay, anyway half and half will get cancelled, right? Half will get cancelled. Then m omega square will get cancelled, right? So now solve this, you will get x equal to 0.71 ampere, 0.71 a. A is amplitude. Okay, the correct option is B. Understood? Yeah. X is the distance, right? Distance at which kinetic energy is equal to potential energy. Okay. Question number 14. A body of mass 5 kg at rest is rotated for 25 seconds with a constant moment of force 10 Newton meter. That is, the torque tau acting on the body is 10 Newton meter, right? Isn't it? 5 kg body initially at rest, okay, is rotated for 25 seconds. It is rotated for 25 seconds. Okay. Find the work done if the moment of inertia of the body is 5 kg meter square. Simple one, right? So the work done by the moment of force W is equal to tau dot theta or tau into theta. Okay, tau into theta. What is theta? Angular displacement, right? So you know that in work energy power, the work if body is moving in a linear motion, okay, or if body is not rotating, if body is in motion, okay, so then the work done is force into force dot displacement, isn't it? Yeah. So in this case, work done is moment of force, that is tau or torque dot angular displacement. Okay. So now W is equal to, so what is torque? Torque is 10 Newton meter, but we need to find the moment of inertia of the body. Sorry, we need to find the angular displacement. So how to find angular displacement? Moment of inertia of the body is given and the time is also given, right? So the here apply second equation of motion for rotating body. So that is theta is equal to omega naught t. Omega naught is initial angular velocity. Initial angular velocity is 0, right? So this whole term will be 0 plus half into alpha. Alpha is angular acceleration into t square. Okay. So now solve this. Here you will get theta. Okay. Here, okay. Before that, theta is equal to half alpha. Here moment of force is given, that is torque is given, and the moment of inertia of the body is also given, that is torque tau is equal to I into alpha. We know the relationship between torque, I and alpha, right? Isn't it? Newton's second law of motion for rotating body. So half alpha is tau divided by I into t square. Okay. So now here we need to find theta, right? So theta is equal to half. Okay, I will substitute directly to this equation. Okay. So now W is equal to tau into theta is half into tau divided by I into t square. So now substitute the values. Okay, tau is 10 Newton meter and alpha is tau by I, right? I is 5 kg meter square and t is 25. So solve this, you will get 6250 joule. Okay, yeah. Question number 15. In the normal adjustment of an astronomical telescope, the objective and eyepiece are 32 centimeter apart. That is the length of the telescope, right? That is 32 centimeter. So now L is equal to 32 centimeter. So which is equal to Fe plus Fo, right? If the magnifying power of the telescope is 7, that is M is equal to Fo by Fe, which is equal to 7, right? Find the focal length of the objective and eyepiece. Simple, right? We have two equations. Solve these two equations. So now Fo is equal to 7 times Fe. Substitute 7 times Fe to this equation. Then Fe plus 7 times Fe is equal to 32. So this is 8 times Fe. So Fe is equal to 4 centimeter. Right? Fe is equal to 4 centimeter. Correct. Right? And then Fo, substitute the value of Fe to any one of this equation, you will get Fo equal to 28 centimeter. The correct option is D. Okay. Yeah. Next question. Question number 16. In a given semiconductor, the ratio of the number density of electron and number density of hole is 2:1. That is Ne by Nh is equal to 2/1. Okay. So if 1/7 of the total current is due to the hole and the remaining is due to the electron. Okay, so 1/7 of the current, the total current is due to the hole, right? So E equal to I divided by 7. I is the total current. And then the remaining is due to the, this is hole and this is electron. Okay, and the remaining is due to the electron. So remaining will be 6I divided by 7, right? So we need to find the ratio of the drift velocity of the holes, ratio of the drift velocity of the holes to the drift velocity of the electrons, right? Okay, so let us find. So we know the relationship between current and drift velocity, right? So what is the formula? I equal to N E A V D. What is N? Number density of the charge carrier. E is charge of the electron. A is area of cross section of the wire. Vd is drift velocity of the charge carrier. Okay. So now for hole IH is equal to I by 7. So which is equal to NH into E into A into VDH. Okay. So then IE is equal to 6I by 7 equal to NE A VD NE into E VD here E. So we need to find VDH by VE. So now substitute this equation by this equation, that is first equation by second equation. Okay, sorry, divide first equation by second equation. Then you will get 1 divided by 6, right? Isn't it? So 1 divided by 6 is equal to NH by NE. So NH by NE is 1 by 2. EA will get cancelled into VDH by VDE. So now solve this, you will get the ratio 1 by 3. Okay, so which is equal to 1 by 3. The correct option is D. Okay, yeah. Next question, question number 17. If A is the aerial velocity of a planet of mass m, then its angular momentum is. The direct question, right? Even in board they don't ask these kind of question. Okay, yeah. What is the aerial velocity? Aerial velocity is dA by dt, right? So which is equal to angular momentum L divided by 2m, right? Angular momentum L divided by 2m. So aerial velocity is A, so angular momentum L equal to 2ma. The correct option is C, right? Yeah. Question number 18. When a particular wavelength of light is used, the focal length of a convex mirror is found to be 10 centimeter. Okay, if the wavelength of the incident light is doubled, keeping the area of the mirror constant, the focal length of the mirror will be. Direct question, right? Focal length of the mirror will be same. Focal length of the mirror does not depend on the wavelength, right? So option D is the correct answer. Yeah. Question number 19. The mass of a particle A is double that of the particle B. Mass of the particle A is double that of B, and the kinetic energy of B is 1 by 8th that of A. So kinetic energy of B is 1 by 8th that of A. Then the ratio of the de Broglie wavelength of A to that of B, that is lambda A divided by lambda B, we need to find, isn't it? So we know that de Broglie wavelength lambda is equal to h divided by P. We know the relationship between momentum and P is momentum and the kinetic energy, right? So now lambda is equal to h divided by root of 2mk, right? Root of 2mk. So now lambda A is equal to, so 1 by h will get cancelled, right? So this will be root of 2mb into kb whole divided by root of 2ma, okay, whole divided by root of 2ma into ka, right? So now 2 will get cancelled, root 2 will get cancelled. Here root of mb, right? Mb into kb is 1 by 8 divided by root of ma is 2mb into kb. So this is ka, right? Ka, right? Isn't it? Kb is 1 by 8 times Ka. So then Ka. So Ka will get cancelled. So this will be root of MB will also get cancelled. So this will be root of 1 by 16. Root of 1 by 16 is 1 by 4. So this will be 1 by 4. So lambda A by lambda B is equal to 1 by 4, which is equal to 1:4. The correct option is C. Okay. Yeah. Question number 20. A coil of inductance 1 Henry and resistance 100 ohm is connected to an alternating current source of frequency 50 by pi 50 divided by pi hertz. Okay, so the frequency is 50 by pi, and then R is 100 ohm. Okay. Here L is 1 Henry. What will be the phase difference between the current and voltage? Okay, we need to find the phase difference between current and voltage. We know that tan phi is equal to XL divided by R. What is XL? Omega into L, right? So tan phi is equal to omega into L divided by R, right? So what is omega? 2 pi f, right? So tan phi is equal to, omega is angular frequency, that is 2 pi f. So 2 pi into f, that is 50 divided by pi into L. L is 1 Henry divided by R is 100. So solve this, you will get phi equal to tan inverse of 1. Okay, so pi will get cancelled. 50 into 2 is 100. 100 divided by 100 is 1. So phi equal to tan inverse of 1. We know that tan inverse of 1 is 45 degree. That is pi by 4. Right? 45 degree. The correct option is D. Okay. Yeah. Question number 21. The current through conductor is A when the temperature is 0 degrees Celsius. Okay. It is B when the temperature is 100 degrees Celsius. The current through the conductor at 220 degrees Celsius. Again, this one is also simple one, but the calculation is involved. Okay, the more calculation is involved. So we know that the temperature, resistance dependent on the temperature, right? So the temperature at T degrees Celsius is equal to R naught, that is the resistance at reference temperature, into 1 plus alpha into delta T, right? So for first case, here our reference temperature is 0 degrees Celsius. So the resistance is R. Okay, so the current, the conductor will be A, right? The applied potential is same in both cases. So therefore, the current I is equal to V divided by R, right? So now current at 100 degrees Celsius, okay, current at 100 degrees Celsius is, right, which is equal to, here V is the voltage, right? So V divided by R, right? So current is A when the temperature is 0 degrees Celsius, isn't it? So R is equal to V divided by I. Okay. So now R is equal to V by I. So now here RT will be equal to V divided by IT. Okay, that is I100. So anyway, V will get cancelled both sides. So 1 divided by current at 100 degrees Celsius is A, which is equal to R naught. R naught is V divided by A, right? So V divided by I is A, that is the current at 0 degrees Celsius. So V will get cancelled, right? So 1 divided by, so this is 1 by B, sorry, 1 by B. So this is 1 by A into 1 plus alpha into 100. Okay, so this is the first equation. Now the second equation, right? So here the current is, let's say C. Okay, current is C when the temperature is 220 degrees Celsius. So 1 by C is equal to 1 divided by A into 1 plus alpha into 100, sorry, 220, right? Alpha into 220. So this is the second equation, right? Solve the first equation and second equation, you will get here C is equal to 5AB divided by 11A minus 6B. The correct option is C. Okay. Yeah. Question number 22. Which of the following graph shows the variation of the velocity with mass for constant momentum? Okay, variation of velocity with mass for constant momentum. Momentum is constant, right? What is momentum? Momentum is m into v, right? Momentum is constant. So m into v is equal to constant k. So m equal to k by v, right? So k is constant, right? From this I can conclude that m is inversely proportional to v. So the graph would be the first one, right? Isn't it? So the correct option is B, figure 1. Question number 23. For a 30 degree prism, when ray of light is incident at an angle 60 degree on one of its faces. Okay, so angle of prism is 30 degree, A is equal to 30 degree, okay, and angle of incident is 60 degree, that is I equal to 60 degree, right? On one of its faces, the emergent ray passes normal to the surface, that is angle of emergence is equal to 0 degree, right? Then the refractive index of the prism. Okay, we need to find the refractive index of the prism, right? Okay, so here we know that delta equal to I plus E minus A, right? Delta equal to I plus E minus A, isn't it? So for minimum deviation, so what is the value of E, right? Sorry, what is the condition? For minimum deviation, the condition is I equal to E, right? And I equal to E for minimum deviation, okay, and R1 equal to R2, right? R1 equal to R2 for minimum deviation, the condition for minimum deviation, right? So therefore here R2 is equal to 0, right? Isn't it? Angle of emergence is equal to 0. So this is the incident light, okay? Then the ray will travel, okay? So then it is normal to the this surface, right? So angle of incidence I. Here this is R1. So R2 is equal to 0, right? Because angle of emergence is equal to 0, isn't it? Why? Apply Snell's law at this point. So mu into sine R2 is equal to 1 into sine E. So E is 0. So R2 will also be 0, right? Isn't it? So now R2 is equal to 0, right? Isn't it? So now apply Snell's law at this point. Okay. So now R1 equal to A, right? Why it is R1 equal to A? Because R1 plus R2 is equal to A, right? R2 is equal to 0. So R1 has to be equal to A, right? So now apply Snell's law at this point. So now 1 into sine I, what is the value of I? 60 degree, equal to here mu into sine R, that is R1. Sine R1 is 30 degree. Okay, sine 60 degrees root 3 by 2, sine 30 degrees 1 by 2. So mu equal to root 3. The value of mu is root 3. The correct option is A. Okay, yeah. Question number 24. A coil offers a resistance 20 ohm for a direct current. Okay, coil offers a 20 ohm for direct current. If we send alternating current through the same coil, the resistance offered by the coil alternating current will be simple, right? Here the alternating current is I. I is equal to V divided by the coil has inductance, right? Isn't it? So the reactance of the coil will be XL, right? Isn't it? So as the value of frequency increases, that is the resistance of the coil in AC situation, okay, resistance of the coil depends on the frequency of the AC current, isn't it? Frequency of the AC current. So if AC is greater than, if frequency of the AC current increases, current will be decreases, right? So therefore the resistance of the coil is greater than 20 ohm, right? The correct option is B. Okay, yeah. Question number 25. A square shaped aluminum coin weighs 75 gram, sorry, 0.75 gram, and its diagonal measures 14 millimeter. Okay, diagonal measures 14 millimeter. It has equal amounts of positive and negative charges. That is, the aluminum is at neutral, right? Suppose those equal charges were concentrated in two charges. Okay, those equal charges were concentrated in two charges, plus Q and minus Q, right? That are separated by a distance equal to the side of the coin. Okay, so first we need to find the side of the coin, right? The dipole moment of the dipole is, okay, so we need to find the dipole moment of the dipole. So the dipole moment of the dipole, P is equal to magnitude of the total charge, Q, into the separation between the charges, right? That is L. Magnitude of the charge into the separation between the charge, that is equal to the side of the square coin, right? Square shaped coin. Okay, so let us find L, that is the difference, the distance between the two charges. Okay, so now the distance between the two charges, right? So how to find? The diagonal of the square is given, right? 14 millimeter. So we know that diagonal D is equal to root 2 times side of the square, right? So now L is equal to D divided by root 2. D is 14 millimeter. Okay, So let us find Q. So how to find Q? That is the charge in the aluminum coin weighs 0.75 gram, right? So now the total number of the atoms, let us find the total number of the atoms in the present in the aluminum coin. So that is N is equal to Avogadro number 6.022 into 10 to the power 23 whole divided by atomic mass of the aluminum that is 27 into the given mass 0.75, right? Isn't it? So now here solve this, okay? So then you will get the number of atoms, right? So let us find number of charges. So the total charge Q is equal to the number of atoms N into E, the charge of the number of atoms into the charge of the one aluminum atom. So what is the charge of the one aluminum atom? Each aluminum atom contains 30 number of protons, 30 number of electrons, isn't it? So the charge of the aluminum will be N into 13 into E, right? N into 13 into E. So we got the value of Q, right? So now P is equal to Q, that is N into 13 into E. E is the charge of the electron or charge of the proton, okay, charge of the proton. N, so Q into L, right? L is T divided by root 2. So now P is equal to N 6.022 into 10 to the power 23 divided by 27 into 0.75 into 13 into E, that is 1.67, okay, 1.6 into 10 to the power minus 19 into D by root 2, that is 14 millimeter divided by root 2. So now solve this, you will get P is equal to 348 coulomb meter. 348 coulomb meter. The correct option is D. Okay. Yeah. So next question number 26. If the Earth has mass 9 times and radius 4 times that of planet X. Okay. So mass of the Earth is 9 times mass of the planet X. Radius of the Earth is equal to 4 times radius of the planet X, right? The ratio of the maximum speed required by the rocket to pull out of the gravitational force of planet X to that of the Earth. Okay, so here V, that is the maximum speed required by the rocket to pull out of the gravitational force. V is equal to root of 2gm divided by r, right? So what is this? Escape velocity, right? So now Vx divided by Ve is equal to, anyway, root of 2g will get cancelled. So root of mx by rx whole divided by root of me divided by re. So me is 9mx, re is 4rx. So Vx divided by Ve is equal to 2 by 3. The correct option is A. Okay. Yeah. Next question. Question number 27. Two similar coils A and B of radius r and number of turns n each are placed concentrically with their planes perpendicular to each other. That is, this is one coil and this is the another coil. Okay. If I is the I and 2I, the respective currents passing through the coils. Okay. So here the current is I. Okay. And here the current is 2I. Then the magnetic induction at the center of the coils will be. Okay. We need to find the magnetic induction at the center of the coil. Right. So now here, due to the first coil, the current will be, the magnetic field at the center will be towards right, isn't it? Due to the second coil, the magnetic field at the center will be in upward direction, right? Isn't it? So here, what is the magnetic field due to the coil, the n number of coil at its center. So B equal to mu naught Ni divided by 2R. Mu naught Ni by 2R, right? Okay. So now here for second coil, right, magnetic field, so this is B1 and B2 will be mu naught N 2I divided by 2R, right? So now take the resultant of these two magnetic field, because magnetic field is vector, right? So it is a vector quantity. So now the resultant magnetic field, so this is the net magnetic field or resultant magnetic field. So B net is equal to root of 1 plus 2 square, that is 4 into mu naught Ni divided by 2R. So now solve this. B net is equal to root 5 into mu naught I into N divided by 2R. So the correct option is B. Okay, yeah. So the next question, question number 28. An ideal diode is connected in series with capacitor. Okay, ideal diode connected in series with the capacitor. The free ends of the capacitor and the diode are connected across 220 volt. Okay, free ends of the capacitor and diode are connected across 220 volt. That is BRMS, right? 220 volt V source. Okay, AC source. Now the potential difference across the capacitor. The simple one, right? The potential difference across the capacitor VC is equal to 220 into root 2. So VC is equal to 311 volt. The correct option is B. Okay, yeah, understood. So next question, question number 29. Which of the following statement is true regarding center of mass of the system? Okay, let's check. Option A, the center of mass depends on the size and shape but does not depend on the distribution of mass of the body. Okay, so here this statement is false, right? Isn't it? Center of mass depends on the size and shape but does not depend on the distribution of mass of the body. This statement is wrong, right? The second statement, the center of mass depends on the coordinate system. This one is also wrong, right? The third one, center of mass of system depend on the size and shape of the body but independent of the coordinate of the system. Yeah, this one is also correct, right? This one is correct. Option C is correct. Option D, the center of mass of the body always lies inside the body. No, it can lie outside the body. So the correct option is C. Okay, understood? Yeah. Next question, question number 30. The ray of light traveling through medium of refractive index 5/4. Okay, so mu1 is equal to 5/4 is incident on a glass of refractive index 3/2, that is mu2. Okay, the angle of refraction in the glass if the angle of incidence at the given medium glass interface is 30 degree. Okay, so this is the glass and this is the medium M. Here the light incident on the interface, glass medium interface at an angle 30 degree. Angle of the incidence is 30 degree, right? So now it will refract, right? Okay, so we need to find angle of refraction, right? Yeah. So now here, so what is 5/4? The 5/4 is 1.24, right? Sorry, 1.25, isn't it? And 3/2 is 1.5. So the refractive index of the medium, that is mu1, is lesser than mu2, right? So here the refracted ray moves away from the normal, right? Refracted ray moves away from the normal. Understood? We need to find this angle of refraction. Yeah, apply Snell's law at this point. So sine mu1 into sine I is equal to mu2 into sine R, right? So sine R is equal to mu1 divided by mu2 into sine I. So now sine R is equal to mu1 divided by mu2. Mu1 is 5/4, right? 5/4 divided by mu2, 3/2 into sine I. Sine I is sine 30 degree, that is 1/2. So sine R is equal to 5 divided by 12. Okay, so I equal to sine inverse of 5/12. Okay, so the correct option is C. The ratio of the radii of the two element x and y having the mass number 232 and 29 is? The simple one, right? So we know the formula of the radius of the nuclei, isn't it? So what is the formula? The formula is R equal to, sorry, let me choose the pen, red color. Yeah, so the radius of the nucleus, R is equal to R naught, that is the constant, empirical constant, into a to the power 1 by 3, right? What is a atomic mass of the nuclei, right? So here atomic mass of the nuclei is given, right? Isn't it? That is the mass number 232 and 29. 232 is for X and 29 is for Y. So now Rx divided by Ry is equal to R naught. R naught will get cancelled. So Ax divided by Ay to the power 1 by 3. Okay. So what is Ax? 232. What is Ay? 29. So 232 by 29 is 8. So the ratio Rx is to Ry is equal to 8 to the power 1 by 3 is 2, right? Cube root of 8 is 2. So now 2 is to 1. Okay. So what is the correct answer? The correct answer is D. Okay. I hope everybody understood. Yeah. Question number 32. When light wave passes from medium of refractive index mu, medium of refractive index mu to another medium of refractive index 2 mu, the phase change occurs to the light. The simple one, right? So when when the light passes from rarer medium to denser medium, right? So what happens? It's there is no change in the phase of the light, isn't it? So the correct option is D, 0. Yeah. So next one, question number 33. On increasing the temperature of the conductor, its resistance increases because option A says electron density increases. Wrong. So if you increase the temperature, what happens? The thermal velocity of the electron increases, but here the drift velocity decreases, right? That is the relaxation time increases, isn't it? So the correct option is D, relaxation time increases, right? Yeah. So next question, question number 34. The difference in energy level of an electron at two excited levels is 13.75 electron volt. Okay. So energy levels of an electron at two excited level, right? So that is E equal to 13.75 electron volt. If it makes transition from the higher level to the lower energy level, then what will be the wavelength of the emitted radiation? Simple one, right? Here E is equal to Hc by lambda, right? Hc by lambda is equal to 13.75 electron volt. So we can write Hc in terms of electron volt, right? So what is the value of Hc? 1242 electron volt nanometer divided by lambda is equal to 13.75 electron volt. Electron volt will get cancelled, right? So lambda is equal to 1242 nanometer divided by 13.75. Okay, so solve this, you will get approximately equal to 900 nanometer. The correct option is, 900 angstrom, okay? 900 angstrom, not nanometer. 900 angstrom, okay? The correct option is D. Okay, yeah. Question number 35. A string of length 25 centimeter and mass 10 to the power minus 3 kg is clamped at its ends. Okay. Here string of length 25 centimeter, okay, and mass 10 to the power minus 3 kg is clamped at its ends, okay. The tension in the string is 2.5 Newton. The identical wave pulses are generated at one end and at regular interval of time delta t, the minimum value of delta t so that constructive interference takes place between the successive pulses is. Simple, right? For constructive interference, the wave has to here, right? So the wave has to move here, then it will hit the one end, again it will come back, right? Sorry, this is not the wave, like this. The wave will move, okay, towards the one end, and it will hit the one end, and then again it will come back, then only the constructive interference takes place, right? So what is the total distance traveled by the wave? 25 centimeter plus 25 centimeter, so that will be 50 centimeter. Okay, distance traveled by the wave is equal to 50 centimeter. So we need to find the value of delta t, right? So the delta t is equal to distance traveled by the wave divided by velocity of the wave in the string, right? Velocity of the wave in the string. So we need to find velocity of the wave in the string. So now delta t is equal to d divided by, what is the velocity of the wave in the string? Root of t divided by mu. What is mu? Mass per unit length, that is linear mass density of the string, right? Yeah. So now delta t is equal to here 50 centimeter divided by root of t. T is 2.5 Newton divided by mu is mass per unit length, that is 10 to the power minus 3 by 25 centimeter. So 10 to the power minus 3 divided by 25 into 10 to the power minus 2. Okay. So now solve this, you will get delta t equal to 20 millisecond. Okay. Delta t is equal to 20 millisecond. Sorry, 20 millisecond. 20 millisecond. The correct option is D. Understood? Yeah. Question number 36. A cubical box of side 1 meter contains boron gas at a pressure of 100 Newton per meter square. During an observation time of 1 second, an atom traveling with the RMS speed parallel to the one of the edges of the cube was found to make 500 hits with the particular wall without any collision with the other atom. Okay, so the total mass of the box in gram is, okay, here first we need to find RMS velocity of the boron gas, right? So VRMS, we need to find VRMS, right? So we know that VRMS is equal to root of 3 RT by M, right? 3 RT by M. So this is the RMS velocity of the gas, isn't it? So now here, here the observation time of 1 second, okay, during an observation time of 1 second, an atom traveling with the RMS speed parallel to one of the edges of the cube was found to make 500 hits with the particular wall, right? So that is the time here. This is the cubical box, right? So the motion of the boron gas is parallel to the side of the box, right? So in 1 second, so there will be a 500 hits with a particular wall, right? So the total distance traveled by the boron gas is 2L, right? That is 2 meter, isn't it? 2 meter. So the time taken by once, okay, time taken by the boron gas for one collision is 1 by 500, right? So 500 hits in 1 second. So for one collision, the time will be 1 by 500 second. So now the time t for one collision is 1 by 500 second, right? So now VRMS, sorry, here VRMS is equal to the total distance traveled by the boron gas 2L divided by time t. L is 1 meter, right? So VRMS is equal to t is 1 by 500. So 2 into 1 into 1 by 500, that is 1000 meter per second, right? 1000 meter per second. We got the value of RMS, right? Here it is RT by M, right? R is universal gas constant, but we don't know the T, right? The value of T, and M is molar mass, right? Okay, but we know the ideal gas equation. So what is the ideal gas equation? PV is equal to nRT. PV equal to nRT. So what is N? Number of moles, right? So PV is equal to number of moles is weight of the given gas divided by molar mass of the gas into RT, right? RT by M equal to PV by M, right? RT by M is equal to PV by M, isn't it? Okay. So now substitute PV by M to this equation, right? So Vrms is equal to root of 3 PV by M, right? So now Vrms is equal to 1000, which is equal to root of 3 into P is 100 Newton per meter square, right? Into V 1 meter cube divided by M. We need to find the value of M. So solve this, you will get M equal to 0.3 gram. Okay. This is a bit lengthy calculation, right? Yeah. So the correct option is B. Okay. Yeah. Question number 37. Around central part of an air-cooled solenoid of length 20 centimeter and area of cross section 1.4 into 10 to the power minus 3 meter square and 3000 turns, another coil of 250 turns is closely wound. A current 2 ampere in the solenoid is reversed in 0.2 second, then the induced EMF produced in the coil. The simple one, right? Induced EMF produced in the coil is equal to mutual inductance of the coil divided by di by dt. Sorry, into di by dt, right? So di is change in current. So the current is reversed. So initial current is 2 ampere. The final current is minus of minus 2 ampere. That is 4 ampere, right? Okay. So now here E is equal to mutual inductance of the solenoid. So that will be mu naught into N1 into N2 into area of the secondary, area of this one coil, okay, the first coil, A divided by L into di by dt, right? So now E is equal to mu naught is 4 pi into 10 to the power minus 7 into N1, that is 3000 turns, into N2 250 turns, into A is here 1.4 into 10 to the power minus 3 divided by L is 20 centimeter, that is 20 into 10 to the power minus 2 into di is 4 divided by 0.2. So now solve this, you will get induced EMF as 1.32 into 10 to the power minus 1 volt. Okay, so the correct option is A. Question number 37. A circular coil of radius 0.1 meter is placed in the XY plane and current 2 ampere is passed through the coil in the clockwise direction when looking from the above. Okay. So let us draw the diagram. X, Y, Z. Okay. So now here the circular coil is placed. Right? Circular coil is placed. Okay. Circular coil, a rough diagram. Okay. So from the above, the direction of the current is clockwise. Okay. From this point of view, that is plus Z or positive Z direction. Okay. From the above, the direction of the current is clockwise. Okay. Find the magnetic dipole moment of the current loop. So what is magnetic dipole moment? Magnetic dipole moment is equal to I into A, right? So current is in clockwise direction, right? So the direction of the area is in negative Z direction. Okay. So now the magnetic dipole moment M is equal to current. The current is 2 ampere into area. Area is here pi into 10 to the power minus 2 meter square, right? So M equal to 0.02 pi ampere meter square. Okay. So this is the magnetic dipole moment, right? So what is the direction of the magnetic dipole moment? It is in negative Z direction, right? Negative Z direction. So the correct option is B. Okay, yeah. Question number 39. A body is moving along circular path. Okay, body is moving along circular path R with the frequency of revolution numerically equal to the radius of the circular path. Okay, frequency of the revolution numerically equal to radius of the circular path. So what is frequency? Frequency is 1 by time period, right? 1 by time period. So what is time period? Time period is equal to 2 pi r divided by v, right? V is the speed of the particle, right? So frequency of the revolution numerically equal to the radius of the circular path. So f is equal to r, numerically equal to the, okay. What is the acceleration of the body if radius of the path is 5 by pi meter? Okay, so we need to find acceleration of the body. So acceleration of the body, okay, acceleration of the body is equal to v square by r, right? V square by r, isn't it? So now here r is equal to f, right? So f is equal to 1 by t, that is v divided by 2 pi r, right? V divided by 2 pi r, isn't it? Yeah. So now here v divided by 2 pi r, right? So v here 1 by t is frequency, right? So 1 by t is frequency. So frequency equal to r, right? Frequency equal to r. So now r is equal to v divided by 2 pi r. So v is equal to 2 pi r square, right? V is equal to 2 pi r square, isn't it? So now substitute the expression of v to this equation. So a is equal to v square, that is 4 pi square into r to the power 4 divided by r. So this will be r cube. So a is equal to 4 pi square into r is 5 divided by pi. So pi will get cancelled, right? So this is r square. So 25 divided by pi square, right? So this will be 25 divided by pi square, right? So this is r cube. So 5 cube is 125. Okay, sorry, 125 divided by pi cube. So pi square will get cancelled, right? Acceleration a equal to 125 into 4 is 500. So 500 divided by pi meter per second square. The correct option is D. Okay, yeah. Question number 40. Which of the given dimension formula represents heat capacity? So heat capacity C is equal to delta Q divided by delta T. Delta Q, what is the dimension formula of the delta Q? That is equivalent to the dimension formula of the energy, that is m L square T to the power minus 2. What is the dimension formula of the delta T? That is the temperature, the change in temperature, or the dimension formula of the temperature is K. So heat capacity C is equal to m L square T to the power minus 2 K to the power minus 1. Okay, so the correct option is A. Next question, question number 41. If potential in volt in a region expressed as V of xyz equal to 6xy minus y plus 2yz, the electric field in Newton per coulomb at point 1, 0, 1 is, okay, we need to find electric field at point 1, 0, 1. They have given potential in terms of x, y, z, right? We know the relationship between electric field and electric potential, right? So what is the relationship between electric field and electric potential? So E vector is equal to minus of dou v by dou x I cap plus dou v by dou y j cap plus dou v by dou z k cap. Okay, so that is here what is the meaning of dou v by dou x? That is partial differential equation, right? So in partial differential equation we differentiate function with respect to x, keeping y and z as constant. Here the function is the electric potential in terms of xyz. Yeah. So now E vector is equal to minus of, now differentiation of V with respect to X, keeping Y and Z as constant. So this will be 6y, 6y minus 0 plus 0. Okay, 6y I cap. Now differentiation of V with respect to Y, keeping X and Z as constant. Here this will be 6x minus 1 plus 2z. So 6x minus 1 plus 2z j cap plus differentiation of V with respect to Z, keeping X and Y as constant. So it will be just 2y. Yeah. So 2y k cap. Okay. So now solve this, you will get electric field at point 1, 0, 1. Now substitute the value of 1, 0, 1. X is 1, Y is 0, Z is 1, Z is 1. So minus 7 j cap. The correct option is A. Okay. Yeah. Question number 42. The closest approach of an alpha particle when it makes a head-on collision with a gold nucleus, is 10 into 10 to the power minus 14 meter. Then the kinetic energy of the alpha particle is the simple one, right? At the closest distance, okay, at the distance of closest approach, kinetic energy completely converts into potential energy. So now the kinetic energy of the alpha particle is equal to potential energy of the alpha particle, that is K into ZE. Z is 79 for gold, right? 79 into E into, for alpha particle it is 2, right? So 2E. So 2 into E divided by the distance between the gold nucleus and the alpha particle is, that is the distance of closest approach is 10 into 10 to the power minus 14, that is 10 to the power minus 13, right? So now kinetic energy of the alpha particle is equal to 9 into 10 to the power 9 into 79 into 10 to the power, 79 into 2, okay, into 1.6 into 10 to the power minus 19 squared divided by 10 to the power minus 13. So now solve this, you will get 3.64 into 10 to the power minus 13 joule. Okay, the correct option is D. Next one, question number 43. A 1 kg block of ice at minus 1.5 degrees Celsius falls from height of 1.5 kilometer and is found melting. The amount of ice melted due to fall, if 60% energy is converted into heat, is, okay, 60% energy converted into heat, right? That is the potential energy, 60% of the potential energy converted into heat, right? So what is the potential energy of the block? So the potential energy of the block is mgh, right? So 60% of potential energy, converted into heat, right? So now the potential energy PE is equal to M is 1 kg into G is 10 meter per second square into H is 1.5 kilometer, that is 1500 meter, right? So 1500 into 10 is 15,000. So potential energy is equal to 15,000 joule, right? 15,000 joule. 1 joule is equal to 4.2 calorie, right? So now potential energy is equal to 15,000 into 4.2 calorie, isn't it? Yeah. So now here we have converted joule to calorie, right? So now 60% of the potential energy, right? So 60% of the potential energy is 0.6 times potential energy, which is equal to the heat, right? So now here the 0.6 times potential energy, that is 0.6 into 15,000 into 4.2 equal to, now the heat is M into LF, latent heat of fusion, plus MC dt. C is heat capacity of the ice, right? Specific heat capacity of the ice, We know the specific heat capacity of the ice. We know the LF, right? Latent heat of the fusion is given. Specific heat of the specific heat capacity of the ice is given, right? dt is here, final is 0 degree, right? Initial is minus 1.5. So final minus initial is 1.5 degrees. So dt is 1.5 degrees Celsius. So now substitute the values, you will get m equal to 16.9 gram. Okay, 16.9 gram. So the correct option is C. Okay, so here you have to you just have to put the numbers, okay, or the values, you will get the answer, the value of m. Okay, question number 44. 64 raindrops of the same radius are falling through air with a steady velocity of 0.5 meter per second. If the drops coalesce, the terminal velocity would be. The simple one, right? We know that the terminal velocity Vt is directly proportional to the radius of the square of the radius of the drop, right? Okay, so now radius of the bigger drop is capital R. Okay, so volume of the bigger drop is 4 by 3 pi r cube, right? So volume of the bigger drop is equal to 64 volume of the 64 raindrops, right? So that is equal to 4 by 3 pi small r cube. Small r is the radius of the small drop into 64, isn't it? So now 4 by 3 pi will get cancelled, right? So r cube is equal to 4 into 64 into r a small r cube. So r is equal to 4 times r, right? Okay, so now the terminal velocity of the bigger drop, right? So terminal velocity of the bigger drop divided by terminal velocity of the smaller drop is equal to, here the radius of the bigger drop squared divided by radius of the smaller drop squared, right? So now Vt divided by Vtb divided by Vts is equal to, here r is equal to 4r, right? So r will get cancelled, 4 square is 16, so 16. So now Vt of the bigger drop is equal to 16 times 0.5 into 10 to the power minus 2 meter per second. Okay, 16 into 0.5 is 8. So 8 into 10 to the power minus 2 is 0.08, right? So this will be 0.08 meter per second. The correct option is B. Okay, the correct option is B. Next question, question number 45. The capacitance of parallel plate capacitor is 400 picofarad. It is connected to an AC source of 100 volt having the angular frequency 100 radian per second. If the RMS value of the current is 4 microampere, RMS value of the current is 4 microampere. Okay, remember the displacement current will be same, right? Because the source is AC source, right? Isn't it? The source is AC. If the source is DC, okay, so then the conduction current is not equal to the RMS value of the current. Okay, sorry, here the conduction current is not equal to the displacement current if the source is DC. If this, here the source is AC, so therefore the conduction current, that is IRMS, is equal to the displacement current. The correct option is C. Okay, yeah. Question number 46. Though tin and silicon are fourth group elements, tin is metal while silicon is semiconductor because option A has tin has more electrons than silicon. No, this is wrong, right? The energy gap of tin is 0 volt while the silicon is 0.07 volt. Actually this has to be 0 electron volt and 0.07 electron volt. So that's why the silicon is a semiconductor, right? Because the energy gap is more compared to the tin, right? So the correct option is B. Yeah. Next question, question number 47. 5 charges Q each are placed at the corners of regular pentagon of side A as shown in the figure, first charge from A is removed with other charges intact, then charge at A is repelled with an equal opposite charge. The ratio of the magnitude of the electric fields at O without charge at A and that of equal and opposite charges at B. Okay. At A is. Okay. So now here, when the charge is at A, what is the electric field at the center? That is, what is the electric field at O? The electric field at O is 0, right? Why? Because of the symmetry, isn't it? Draw a straight line here. So now it is a symmetry, right? Isn't it? This side and this side. So this side is the mirror image of this side, or vice versa, isn't it? So this is symmetry, right? And all charges are equidistant from the O, right? So electric field at O will be 0. Okay. So now the charge at A is removed, isn't it? The charge at A is removed. Okay. So now here, anyway electric field is 0 at O, right? So electric field due to 4 charges is equal to, plus charge at A, which is equal to 0, right? So now electric field due to 4 charges is equal to electric field due to charge at A, right? Actually minus of, I took the magnitude. So now electric field due to 4 charges is equal to electric field due to the charge at A is kq by r square, right? So kq divided by r square. So this is the first equation. Okay. So now the negative charge is placed, right, on A. So now here negative charge is placed, right? So now the net electric field is equal to kq by r square, right? kq by r square. So which is equal to electric field due to 4 charges plus electric field due to 4 charges plus electric field due to minus q charge, right? Electric field due to minus q charge. So here this has to be kq by r square, not kq square. Okay. So now electric field due to 4 charges, will be 2 kq by r square. So this is the second equation. Now divide the first equation by second equation. You will get the ratio 1:2. The correct option is D. Okay. Yeah. Question number 48. Two circular coils of radius A and 2A are placed coaxially at distance x and 2x respectively from the origin along x-axis. Okay, let us draw the diagram. So this is the origin. Okay, so here the coil is placed. The radius of the coil is A. Okay, the distance between the center of the coil and the origin is x. Now another coil is placed at 2x, at distance 2x from the origin. The radius is 2a. Here the radius is a. Okay, here the distance will be 2x from the origin. So the remaining distance will be x, right? Okay, between the centers of the two coils, the distance is x. Okay, if their planes are parallel to each other and perpendicular to the x-axis and both carry the same current, okay, both carry the same current in the same direction, okay, sorry, both carry the same current in the same direction, then the ratio of the magnetic field induction at the origin to the smaller coil to that of bigger one is the simple one, right? If you know the formula of the magnetic field due to the circular coil at point which lies on the axis of the coil, okay, so then you can easily solve this question. So now the magnetic field at the origin due to the smaller coil is mu naught I, okay, mu naught I into r square divided by 2 into r square plus x square to the power 3/2, right? So what is r? That is the radius of the smaller coil. So radius of the smaller coil is A, right? So I will write A. So A square and A square. So now magnetic field due to the bigger coil at the origin is BP, okay, which is equal to mu naught I into, here the radius is 2A, so 2A whole square is 4A square divided by 2 into A square, here 2 into 4A square, okay, 4A square plus 4x square to the power 3 by 2. So now magnetic field due to the bigger coil is equal to 4 mu naught I into A square divided by here take 4 as common, okay, 4 as common, so then root of 4 is 2, 2 cube is 8. So now 2 into 8 into A square plus x square. So now this will be 1 by 2, right? So now B due to bigger coil is equal to mu naught I A square divided by 2 into 2 A square plus x square. So this is the first equation and the second equation, okay, second equation. So now divide the first equation by second equation, okay, divide first equation by second equation, you will get the ratio 2:1. The correct option is A, okay, yeah. Question number 49. A metallic rod of 2 meter length is rotated with the frequency 100 Hz. Okay, it is rotated with the frequency 100 Hz about an axis passing through the center of the circular ring of radius 2 meter. The constant magnetic field 2 Tesla is applied parallel to the axis and perpendicular to the length of the rod. The EMF developed across the ends of the rod. The simple one, right? So use this formula here, E equal to B omega L square divided by 2. Motional EMF, right? If rod is rotating in a magnetic field, okay, magnetic field, so then induced EMF produced in the coil is B omega L square divided by 2. So now E is equal to B, here B is 2 Tesla, okay, into omega is 2 pi f, so 2 into pi into f is 100 Hz into L square is 4 divided by 2. So now solve this, you will get E is equal to 800 pi volt. The correct option is A, okay, yeah. Question number 50. The power of a gun which fires 120 bullets per minute with a velocity 120 meter per second is, given mass of the each bullet is 100 gram. Again the direct question, right? So power is equal to energy divided by time. So what is the energy? Energy is the energy of the 120 bullets, right? So N into kinetic energy of the each bullet, N is equal to 120, okay, this is N. V is 120 meter per second, so divided by the time is 1 minute, right? So in second it will be 60. So now P is equal to N is 120 into 1 by 2 into mass is 100 gram, that is 0.1 into V square is 120 squared into 1 by 60. So solve this, you will get P is equal to 1.44 kilowatt. The correct option is C, okay, yeah. Question number 51. The width of the fringes obtained in the Young's double slit experiment is 2.6 millimeter. So this is beta, okay, fringe width. When light of wavelength 6000 angstrom is used, if the whole apparatus is immersed in a liquid of refractive index 1.3, the new fringe width will be, simple one, right? So here the new fringe width B dash is equal to original fringe width divided by mu, right? So now beta dash is equal to, beta is 2.6, right? So 2.6 millimeter, isn't it, divided by here divided by mu, right? So width of the object here mu is given, right? 1.3. Yeah. So now beta dash is equal to 2 millimeter. The correct option is C. Okay. Yeah. Question number 52. An electric bulb of volume 300 centimeter cube, that is V is equal to 300 into 10 to the power minus 6 meter cube, okay, was sealed off during manufacture at pressure of 1 millimeter of mercury. So what is the pressure? The pressure will be 1 millimeter of mercury, that is pressure is equal to density of the mercury into G into H. So P is equal to density of the mercury is 13.6 into 10 to the power 3 kg per meter cube, right, into G, that is 10 into H, 1 millimeter, that is 10 to the power minus 3, okay, minus 3 here, Newton per meter square, at 27 degrees Celsius, okay, at 27 degree Celsius. So T is equal to 300 Kelvin. Yeah. The number of air molecules contains in the bulb. So R value and Avogadro number is given, right? So we know that PV is equal to N into KB into T, right? So what is N? The number of molecules, right? So what is KB? KB is Boltzmann constant. So KB is equal to universal gas constant R divided by Avogadro number Na, right? So what we need to find? Here we need to find the value of small capital N, right? The number of molecules. So now N is equal to PV divided by Na. Na is here N, right? We are finding N. So KB is R by Na. R divided by Na, right, into T. So now N equal to P, okay. So substitute the value of P, here this one, and then Na, okay, and then T 300 Kelvin, and then the value of R, you will get N equal to 9.65 into 10 to the power 18, okay. The correct option is D. Understood? Yeah. Question number 53. Find the binding energy of the tritium nucleus. Simple one, right? So what is binding energy? Binding energy is equal to mass defect delta M into C square. So now binding energy is equal to mass defect, right? So mass defect will be here number of protons, okay, atomic number into mass of the proton, that is total mass of the proton. Total mass of the proton is 1 into MP, right, 1.00782, okay, atomic mass unit. I won't write atomic mass unit, okay, because atomic mass unit into C square is 931 mega electron volt, right? So plus here number of neutrons is here 3 minus 1, right? 3 minus 1 is 2. So 2 into 1.00866 atomic mass unit minus the mass of the tritium, that is 3.01605 atomic mass unit, okay. Here 1 atomic mass unit into C square is 931 mega electron volt, okay. So which is equal to 931 mega electron volt. So solve this, you will get B is equal to 8.5 mega electron volt, okay. The correct option is A, 8.5 mega electron volt. Question number 54. A single slit diffraction experiment for slit width A, the width of the central maxima is B, okay, width of the central maxima is B. If we double the slit width, corresponding width of the central maxima, the simple one, right? So here beta, the width of the central maxima, is equal to n lambda d divided by d, right? So now here the slit width is doubled, that is it will be 2d, right? So beta is equal to, here n is same, right? So beta dash is equal to n lambda, so n is equal to 1, right? So this will be lambda d divided by 2d. So beta dash is equal to 2b by, sorry, beta divided by 2. Beta divided by 2. The correct option is C. Okay. Yeah. Question number 55. Okay, I will read it from here. Okay. Two charges minus q, each are fixed, separated by a distance 2d. Okay. Minus q charges are separated by distance 2d. A third charge q of mass m placed at the midpoint is displayed slightly by x. Okay, so here the q is placed here, right? So it is displaced by x. Sorry, initially the q is placed at the midpoint, then it is displaced by slightly displaced by x, perpendicular to the line joining to fixed charges as shown in the figure. The time period of the oscillation of q will be. That is, they are saying, okay, so let's see whether it performs simple harmonic motion or not, right? So when it is slightly displaced, right? So what happens? Here there will be two forces, right? Isn't it? So this is the resultant force, right? This is the resultant force, isn't it? So now force increases, and so on, right? At the center, okay, when it reaches the midpoint, what happens? Its velocity is maximum, acceleration is 0, right? So then again it will start to move, because at this point this q charge is in stable equilibrium, right? So then it will start to move in downward direction. Okay, so at certain point here, this force, the upward force, will be maximum, right? Isn't it? So that force makes the velocity of the q is 0. Okay, so again it will start to move in upward direction, okay, and downward direction, to and fro motion. Okay, so then we can say that the charge q performs simple harmonic motion, right? Isn't it? So if charge q performs simple harmonic motion, so what is the condition for simple harmonic motion? Then F equal to kx, F equal to k into x, right? So what is k? M into omega square, isn't it? M into omega square. Here k is equal to m into omega square, right? So what is F? Here the F is the restoring force, right? So who is providing the restoring force? Definitely electrostatic force, right? So now electrostatic force, here K, okay, K into, here K into, what is the distance between them? Q d square, right? Okay, K q square divided by d square, right? K q square divided by d square is equal to here k into x, right? K into x. So now, okay, so I will say this is k dash, okay, k dash. Understood? So k into q square divided by d square equal to k dash into x. So what is k dash? M into omega square. What is omega? Omega is equal to 2 pi by t, right? Omega is equal to 2 pi by t. Okay, so now we need to find the time period of the oscillation, right? Isn't it? So we have the expression of omega, so then we have the expression of k dash, we have this one also. Okay, use these three equations, we will get t is equal to root of 8 epsilon naught m into pi cube into d cube divided by q square. Okay, yeah, so the correct option is D. Understood? Yeah. Next question, question number 56. Two metal spheres, one of radius r by 2 and the other of radius 2r respectively, have the same surface charge density. They are brought in contact and separated. The ratio of their new surface charge density is, again this one is also simple, right? So when you brought the two charge spheres in contact, what happens? The charge distribution will take place, right? So each charge will get the, okay, each sphere or two metal sphere get the charge q1 plus q2 by 2, right? Here the Q1 is the charge on the metallic sphere, the first metallic sphere. Q2 is the charge on the second metallic sphere. Okay, so here sigma 1 is equal to sigma 2, right? That is Q1 divided by 4 pi r square by 4. R square by 4 is equal to Q2 divided by 4 pi 4r square, right? So 4 pi will get cancelled, and r square will get cancelled, isn't it? So 4q1 is equal to q2, right? 4q1 is equal to q2. So now when they brought in contact, the charge distribution will takes place. So what is the charge distribution, or the charge on each metallic sphere after they brought in contact? Q1 plus q2 divided by 2, right? Q1 plus q2 divided by 2. Q2 is equal to 4q1, right? So what is the total charge? The total charge Q is equal to Q1 plus Q2, that is 4Q1 plus Q1, 5Q1, right? The total charge is 5Q1. So Q1 is equal to Q divided by 5, right? Q1 is equal to Q divided by 5, and Q2 is equal to 4 by 5. Q2 is equal to 4 divided by 5, isn't it? Yeah. So now it is Q1 plus Q2 by 2, okay, right? Each metallic sphere will get the charge Q1 plus Q2 by 2. So we need to find their new surface charge densities. Okay, so after the charge distribution, sorry, after they brought in contact and then they separated, right? Okay, so here Q1 plus Q2 by 2, right? So each sphere will get charge Q by 2 and Q by 2, right? Each sphere will get charge Q by 2 and Q by 2. So now the new surface charge density, right? That is sigma 1 is equal to Q by 2 divided by 4 pi r square by 4, right? So now here ratio of the new surface charge density, right? Okay, let's find sigma 1. Okay, so then sigma 2 is equal to Q by 2 divided by 4 pi 4r square. So now divide sigma 1 by sigma 2. Sigma 1 divided by sigma 2. Okay, so then you will get 4:1 ratio. Okay, 4 by 1 or 4:1 ratio. The correct option is B. Okay, yeah. Question number 57. Find the value of n in the given equation, P equal to rho n into V square, where P is the pressure, rho is the density, and V is the velocity. Okay, we need to find n, right? Check the dimensions or check the unit. So what is the unit of the pressure? The unit of the pressure is kg, force by area, right? So force is kg meter per second square divided by meter square, that is kg per meter per second square. Okay, or I will write kg divided by meter into second square. So which is equal to rho to the power n, that is kg per, rho is density, right? What is the SI unit of the density? Kg per meter cube. So kg divided by meter cube to the power n into V. V is the velocity, right? What is the SI unit of the velocity? Meter per second. So meter per second squared. So meter square second square, right? So now here, so now kg, solve this. Okay, so now this will be kg meter cube. Okay, so kg meter cube, second square will get cancelled, right? So which is equal to kg divided by meter cube to the power n. So now compare the powers, then you will get n equal to 1. The correct option is B. Okay, yeah. Question number 58. A stone of mass 2 kg is hung from the ceiling of the room using 2 strings. if the strings makes an angle 60 degree and 30 degree respectively with the horizontal surface of the roof, then the tension on the string, the longer string is the given value of G is 10 meter per second square. Okay, let us visualize the situation. Here, this is the roof. Okay, here the first string. Okay, first string, and it is making an angle 30 degree. Okay, with the roof, and this is the second string. So this is making an angle 60 degree. So which one is the longer? This is the first one, right? Isn't it? So this is the stone. The mass of the stone is 2 kg. Okay, 2 kg. So the force due to gravity acting on 2 kg is 20 Newton. So this is T1. Okay, and this is T2. So let's resolve. So now it is in equilibrium, right? Isn't it? So let's resolve T1 and T2. Here, this is T1. Okay, and this is T2. Understood? So what is the vertical component of the T1? Here the vertical component of the T1, so this is 30 degree, so this angle will also be 30 degree. So this angle will also be 30 degree. Sorry, 60 degree, right? So now here vertical component of the first one, so that will be T1 sine 30 degree, right? Isn't it T1 sine 30 degree? Okay, let's write the horizontal component because horizontal components are cancelling each other, right? Because it's in equilibrium. So T1 is equal to T2, right? The horizontal component of the T1 is equal to horizontal component of the T2. So horizontal component of the T1 is T1 cos 30 degree. T1 cos 30 degree is equal to horizontal component of T2 is T2 cos 60 degree. T2 cos 60 degree. Okay. So what is cos 30 degree? Root 3. So root 3 into T1 is equal to T2 into cos 60 degree is 1 by 2. So this is root 3 by 2. So this is 1 by 2. So 1 by 2 will get cancelled. So T2 is equal to root 3 times T1, right? Root 3 times T1, isn't it? Okay. So now here, so let's write the vertical component forces. Okay. So here T1 sine 30 degree. Okay. T1 sine 30 degree plus T2 sine 60 degree is equal to 20 Newton because it is in equilibrium, right? So we have the expression of T2, right? Substitute the expression of T2 to this equation. Okay, substitute the expression of T2 to this equation. Okay, so then you will get the value of T2. Okay, so then from that you will get the value of T1, right? Use that value, so then you will get T1 is equal to 10 Newton. Solve these two equations. So this is the first equation and second equation. Solve these two equations, you will get T1 is equal to 10 Newton. The correct option is C. Okay, yeah. Question number 59. Okay, so this question is not clear. Okay, this question is not clear. Okay, let's move on to the last question. Question number 60. If the ratio of the lengths of radii and Young's modulus of the steel and brass wires in the figure are A, B and C respectively, then the corresponding ratio of increase in their length would be. Okay, so we need to find corresponding ratio in their length, right? So for this mass, right? Here this is mass M, right? So now this is the first block and second block. Mass M, right? So due to gravity, force on M will be mg, right? And the steel wire is connected to the second mass, right? Mass is 2m, isn't it? So now the tension in the string, so it is in downward direction. Okay, so this is T. Okay, so here for 2m mass, the force due to gravity is 2 mg. Here this is tension T. Okay, so now T equal to 2 mg, right? So this is T dash, isn't it? So now the force acting on this M will be here, the T dash, the tension T dash is equal to 3 mg, right? 3 mg. So now what is the increase in length, right? So we know that Young's modulus Y is equal to F into delta L divided by, sorry, F into L divided by A into delta L. F into L divided by A into delta L. Okay, A into delta L. So delta L is equal to F L. Okay, so F into L divided by A into Y. F into L divided by A into Y. Okay, what is F here for delta Ls? Here delta Ls is equal to F is 3 mg, right? 3 mg into Ls divided by A is pi into Rs squared, pi into Rs squared into Ys. Now delta Lb is the change in length of the brass wire, right? So which is equal to here mg, okay, here which is equal to here delta Lb is equal to 2 mg, okay, 2 mg into Lb divided by pi Rb squared into Yb. Okay, so what they are asking? They are asking then the corresponding ratio of increases in their lengths, right? That is delta Ls by delta Lb. They are asking delta Ls divided by delta Lb. Okay, so divide delta Ls by delta Lb. So you will get 2a divided by 3b square into c. Okay, understood? Yeah. Okay, that's it. Okay. Okay, so thank you so much for watching this video. If you love this video, please like and share, and if you want to watch more such videos, please subscribe. Thank you.